Hey everybody, I have a short video here for you for solving quadratic equations numerically on the graphing calculator. We're going to look at three things in this presentation. Before you start, you need to know there's different scenarios on the solution. We'll talk about that in a second. Then we'll talk about how to use the graphing calculator to find these solutions numerically. And then thirdly, when you're solving numerically, there's some issues that can come up about the number of answers, the exact answers, domain, and range. But let's kick it off here with an example. So, I'm sorry, not an example, the possible scenarios that you could run into. There's three things could happen with quadratic equations. Now, I've shown this graphically because it's easy to see the picture real quick that this has two solutions. It intersects twice. Here's a quadratic that has one solution because it intersects once. And here's a quadratic that doesn't intersect at all. So when you're solving quadratics, you can have two solutions, one solution, or no solution. And you need to be aware of that numerically. Now, when we're looking at the numbers, we're not going to see these pictures. And so we'll have to use some clues to decide what we're looking for, one solution, two solutions, or no solution. Okay, so let's take an example here to get it kind of kicked off. I got this equation. It's a quadratic equation, and I want to solve this. So the first thing to notice is it's an x equation. So when I solve, I need answers for x. So first point, realize you're solving for x, and there's probably two. Do not give an ordered pair. It's not an xy answer. It's not an ordered pair. And we're not looking for y answers, although the table is going to show us a lot of y values. Now here's the technique for solving it. What we're going to do is we're going to rip the equation into parts. We're just going to split it right in half and make one equation out of the left half, make another equation out of the right half. And so we're literally tearing the equation into two parts. And then we're going to take those two parts and generate the numbers and look for when y1 equals y2. And we can do that in the table. So, go second. Nope, sorry. We're going to hit the y equals button so we can type in the equations. So 2x squared minus 9. Enter that on the left side into y1. I'm going to take the right side, enter that into y2. 1 minus x. So the two halves of the original equation are now two xy equations that we can generate tables for. And so the table, you may remember, you do second graph button and that'll activate the table command. Second graph, and we get tons of numerical data now. So when 0 is input, -9 is output. That's on the left side. When 0 is input, 1 is output on the right side. And we're looking for when y1 equals y2. And of course, y1 is -9, y2 is 1. They're not equal. But notice y1 is smaller. The next one, y1 is -7, y2 is 0. Not equal, but notice y1 is smaller. Y1 is -1, y2 is -1. Bingo! There is a place where y1 equals y2. So that means x equaling 2 is a solution to this equation because it makes both halves equal to -1. So x is our first solution. Now I mentioned we're generally looking for 2. And so often you're going to want to scroll through the x's, and I'm going to scroll to higher x's, but I see the x numbers get higher and higher, and the y2 numbers are getting more negative. So I'm quickly losing confidence that x is bigger than 2. I think we need to go back and look at the negatives now. So starting at 0, we already found this solution, but let's go back to the negatives and see what happens. When x is -1, y1 is -7, y2 is 2. So -7 is smaller, not an answer. -2, when x is -2, y is -1, which is smaller than 3, still smaller, not an answer. When x is -3, y1 is 9, y2 is 4. Wait, y1 is now bigger than y2. Something has happened between -2 and -3. y1 went from being smaller to being bigger. That means there was a point at which they crossed and they were equal. And it's somewhere in between -2 and -3. Now, you can estimate and just guess and say, oh, about -2.5 then. Or you can use this, you can change the increment. Now, here's a shortcut. Press plus. And plus will change the increment of how x counts. So I'm going to press plus. While I'm in the table, I press plus and I can change the increment for the table. Let's say I change it to 0.5. And now it's going to recalculate all my x's counting by halves. So at -3, we already saw they're not equal, but -2.5, y1 is 3.5 and y2 is 3.5. Another solution. And so when x is -2.5, the two halves of the equation equally to each other. So we have found a second solution numerically. So when you find one, don't give up. Look for another. And the key is you're looking to see when one of the y values switches from being below to above the other y value, because that's where a critical transition has occurred. Okay, so let's discuss a couple of issues that can arise when you're solving numerically. First issue, kind of hinted at it already. You've got to consider that there's two possible solutions. So when you find one, don't give up. But sometimes there's none. And so you have to have some good arguments to give up on the numerical table before you just say, oh, I haven't found it, there's no answers. But sometimes you can make an argument depending on the y-intercepts and other clues like the range and domain. But another question that can come in is, how do you find the exact answers? Because sometimes, like when we did this problem back here, the exact answer may not be -2.5. It may be -2.4 or -2.3, or it may be in between -2.4 and -2.3. And so there's a point in the search where you just call it as an estimate. And you try to get in between the best you can and just say, well, it's approximately -2.4. And so when you're working numerically, many times you're not going to find the exact answer unless they happen to be these nice numbers that I created in that problem. So most of the time it'll be a round off. Another issue though, unknown range and domain. When we don't know the range and domain, we could be searching our x's a long time to find matches. Let me give you an example here. So here we got a practical example. X equals the speed of a car, and f of x is the stopping distance. So if you're going a certain speed, you slam on the brakes, this equation gives us how long it will take the car to stop. So here's our question. What was the speed of the car if it took 200 feet for the car to stop? Well, that is something we can solve. It's a quadratic equation. If we make it into an equation, of course, and that would be our equation. We want the stopping distance to equal 200 feet. And this is something we can solve in the calculator. Now I'm going to stop here and set the calculator up really quick. I just pause things to set up the calculator. You can see I typed the left side and the right side into y1 and y2. I also discovered a typo. I was missing a 0 there in case you saw that before, but it's 0.03x squared. Now I want to solve this numerically. So I'm going to jump in here, do second graph, activate the table command, and I'm looking at this and saying, what are my x's? And it's like, whoa, this is 8 and this is 200. That's going to take a long time if I just scroll down. So I'm going to hit the plus command because I don't know what the domain should be. And instead of counting by ones, this is going to take a long time. Let's count by tens. And so now it's recalculated, 10, 20, 30, 40, and it goes up 180, 200. Wow, that's pretty close. And so when I see it now, 70 is 230, 200. So right here, the change occurred between 180 and 230. I've passed the 200 mark. Now remember, this is speed. So that was a clue. We're talking about speed in miles per hour. So it's somewhere between 60 and 70 miles per hour. So I'm going to go back on the 60. And now I'm going to go to the delta and count by ones again. And so now I can see 64. It's almost 199 feet. So in my mind, that's good enough to call it right there. So I got an estimate. So those are some tricks you can do when you don't know the domain and range. You can change the increment. Another clues you look for is context, like speed. So it wouldn't make sense to go look at negative x because you can't have a negative speed in your car. So those are kinds of clues that you can take to find solutions numerically. Hope this was helpful. Study hard and best of success in your algebra class.